Alrighty, let's start. So today I'm going to be solving this problem. Next permutation. Okay, let's read it aloud. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, for array 1 to 3, the following are all the permutation of ARR array. 1 to 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutation of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order. For example, the next permutation of 1 to 3 will be 1 3 2. Similarly, the next permutation of 2 3 1 will be 3 1 2. While the next permutation of 3 2 1 is 1 2 3 because 3 2 1 does not have lexicographical larger rearrangement. Given an array of integers nums, find the next permutation of nums. Replacement must be done in place and use only constant extra memory. Okay. So, okay, let me open up. Let me prepare. Delete it. Delete this one as well. Alright, here we go. Here's my terminal. Okay, because we are in the directory that we created in the previous program, so I'm going to check out to main, git pull just in case we have something new. I don't think so. I don't merge anything. Okay, just git check out. Oops, the problem, and the name is next permutation. Permutation. Good. So create a directory called ls. Okay. So make directory next permutation and nvim memo.md, and I also want to, what was it, v edit or vsp, bsp. Okay, let me use this one, bsp step 1.py. Hold on. This is memo. Okay, so step 1. Experiment. First things first. Everything starts with experiment. Okay, so experiment. Okay, array given 1 2 3, next permutation will be, so what you'd be thinking, okay, given this array, what you've been thinking is to, okay, first look up the end integer 3, and then if there is anything larger than 3, what would you do? Okay, so let me forget about this for a sec. Okay, so there is nothing larger than 3. Moving on. I mean, what do we want to get? So we want to get 132, right? We're moving on to left. Okay, so 3. So look up index 1, and then we get there is 3. So increment it to 3. Which will decrement 3 to 2. What if array is 1, 4, 2? Or maybe 3. Index 2, that'll be 2. But what do we want to get? 132, next permutation will be 2, 1, 3. But what I'm doing in my head is to, in order to get 2, 1, 3 out of 1, 3, 2, you want to get, okay, so you're going to look at the end of the array, and you want to basically look for something that's bigger than that, and there is something bigger, which is 3. But if we put 3 on the end and put 3 where put 2 where there is 3, it will become 1, 2, 3, which is not the next, definitely not the next permutation. So missing piece is that if when we replacing integers, we need to be careful if after the operation is lexicographically larger than before the operation. Okay, so realization. Okay. if you replace integers, let's say the integer behind where you are going down lexicographically, uh, which means otherwise, if you replace the integer after where you are, so for example, if you have 4 here and then you replace 4 with 2 and 2 with 4, that'll become 1 3 4 2. That's going up in the lexicographical order, my pronunciation. You are going up lexicographically. What is the problem? This should be surrounded by a blank lines. Okay. So you want it, I guess. And I also have to pick up my mom in an hour, so let me write her. And also set an alarm in like 45 minutes, considering the time to get there to pick up her. Let me stop the recording real quick. Right. Have I resumed the recording? Okay, good. So, this is my realization so far. Okay, so going back to the experiment here. So if you want to increment this lexicographically, you want to, okay, so refer to this one. And if you're at the end, there's no operation as such to go up in the lexicographical order. So you want to go from one before, and you want to look up for any larger integer that's going to come after where you are. So okay, look up. Okay, hold on. I'm going to d look up the one before the end. So we have 2, and look up for the value larger than 2 after the current position. There is actually, and that's 3 hits, and swap them. Another experiment that I can come up with hold on. Okay, 2, 3, 4. And what do we want to get? We want to get 1, 2, 4, 3. 1, 2, 4, 3. Okay, that's a good experiment because simply 2, 4, 3. No, the same logic would apply. Okay, so 4, 3. What the fuck just happened? Okay, 4, 3. 4, 3. So you look at the one before. That's 4. There's nothing. Move up to the left. Look out for something bigger, and there's 4. And you want to replace it with a 2. So it becomes like 1, 4, 2, 3. 1, 4, 2, 3. And that's what we want to get. So same logic. Okay, but it's slightly it's slightly introducing a new logic of skipping. So let's just do it. Look at the one before the end, just like that. That'll get you 4. Look for there's a slight English grammatical error there, so look for the value larger than 4 after the current position, which doesn't exist. Nothing hits. Okay, so moving on to the left. How do you say? Moving on to the left. That'll give you 2. Okay, and then same. If you do the same, so now you're at 2. Look for the value that's larger than 2 from your right hand, and that'll give you 4. And if you replace 4 with 2 and 2 with 4, that'll give you 1, 4, 2, 3, which is lexicographically next permutation from what you get right there. Right or no? No, not at all, because lexicographical next permutation is actually 3, so you want to get 3 rather than 4. So that is actually a great example of where people can get wrong. So you want to get, okay, minimum larger. Right. Difficult. Okay, let me forget. Minimum larger. So actually 3 hits. No, not actually. Same as 2, and you get 3. Swap them. There's another grammatical error I found right there. 6. And that will get you 1342. But the answer you want to get is 1324. So, yeah, right? Yeah. So now you are getting 1342. And you want to basically swap 4 and 2. And how is that possible? So right now you are here. That's interesting. That's very interesting. Okay, let me go through with what I'm thinking inside of my head. So, okay, 1, 2, 4, 3. Okay, 1, 2, 4, 3. And I'm thinking to increment this part. There's nothing. And incrementing this part, there's nothing. Incrementing this part, there's actually something. And you want to increment minimum amount, so that's why you're not choosing 4, instead you're choosing 3. So this should hold 3, and once you increment this part, you want to move on to here. And you want to move on to here, and then this has to be, because we increment this part, this wants to become smaller, this wants to become smaller, and when it comes to getting something smaller, you want to look for something smaller from your right hand, and then you get 2. So so what you want to do is to moving on to the right, you get 4. Hold on, I have a call. Excuse me. Okay, so yeah, moving on to the right, and right now you want to get, okay, look for the value minimum smaller than 4 after the current pause. Then you get 2 hits, swap them. And that is the end, I guess. I want to hear another example. Logic hasn't really convinced me. So let's say this has been incremented 5, 7. Okay, so motivation is to motivation is to look for a place where you can incrementally ascend in the lexicographical order, which means you want to start from here and then to go up in the order lexicographical. Okay, you want to swap them here and then that's it. And if you are here, hold up, let me restart. Okay, so okay, in order to increment this, you want to replace 9 with 5, 9 with 8. That's increment. And to increment this, start from here. There's nothing on the left that's bigger than that. Now move on to here. Okay, there's something that you can increment. That's 8. Swap them. And now you want the right part to be the smallest because you incremented this one. And that goes for the same. That's the same goes to this part because you are swapping 9. Okay, so 8, 9. Okay, you are at 8 and then you are swapping 9 and you want the right part to be small as possible. So you move on to 8 and then you are going to look for a value that's large. I mean that's big. No, that's smaller than 8 from right of 8, and there's nothing. Stop right there. Okay. And now we are incrementing this array. In order to increment, okay, let's start from 9. There's nothing to be updated. There's nothing larger than 9. Moving on to the left. There's actually 8, minimum larger value than 7. So swapping them. Okay, that's what we did just right there. And now we want the right part to be smallest. Okay, so moving on to the right of 8, which will give 9, and what you're going to do is look for a value that's smaller, that's minimum smaller than 9, which will give you 7. So okay, you have found one. You want to swap it. Now finish. Moving on to the right. Look for a value that's smaller than 9, plus that's minimum, and there's nothing on the right. Finish right there. Okay, what the fuck is going on? What? Okay, okay, I think it's okay. All right, now increment this. You're going with this and start from here. Okay, that's actually bigger than that. So replace 9 with 7, and because you have incremented this, how do you say this, this digit, let's say this is a digit, you want to move on to the next digit and you want to make it smallest as possible, and there's nothing to be updated. So moving on to the next permutation. Starting from 9, there's nothing to be updated. Moving on to the next, we have 7. Hold up. What we did? Okay, 8. You want larger than 8, so there's 9. Here gets 9, and you want to make this part, this small two digits, to be smallest as possible, and then you move on to 8. Look out for a smaller value from the right part. Yes, you get 7, and then swap them. Okay, starting from here, yes, you get 8, that's larger than the current value. Okay, and then moving on to the next one, there's nothing larger than 8. Moving on to the left, larger than 9, nothing. Then moving on to to 6, there's 7, that's a minimum larger than 6, so swap them. Okay, and then now you have incremented this part. You want this right part to be as minimum as possible. So now you get 9. You want smallest. You want smallest number from your right hand, which will give you 6. Swap them. Moving on, smaller value than 8, there's nothing. So obviously there's nothing. So here's the generalization. Okay, so generalization. Okay, start from the one before the end, n minus 1. Okay, and then first look for a value that's minimal larger than the current value, and then if not, move 1 to the left. That's what we did, right? So for example, there's no larger. For example, here there's no larger, so we are moving on to the left. For example, this one, we have no larger. On the right hand, moving on to the left, there's larger. This is 8. That is 9. Okay. If true, if true, swap then and make the right hand smallest. And in order to make someone smallest, what you're gonna do is to swap them and move to the right for the minimum value. After the current index, okay, to the current index. Okay, if not found, what is going on? Not to say level. Does it have to be something else? For example, okay, it's not saying anything, so I guess. Okay. If not found, finish. If found, swap and repeat .3.1. Actually, I want to make it 3.1 rather than it's not interpreting it. Alright, or maybe I could do something like this. Not sure if this works. Okay, so it was a problem about indentation level, apparently. And then okay, it's not emitting any error. Alright, that's it. That'll finish someday. Okay, that's a generalization. I'm waiting for my mom's call. Because I'm thinking I won't be able to implement before she sends me a text message, but yeah, we'll see. Okay, so that is my understanding so far. Let's move this part right up here. Another experiment. So this is it, and then referring to other approaches. "31st." Okay. Let me open up this one. Hope there's something. I mean, there's definitely other solutions. I'm pretty sure. There's always alternatives. Okay, he says to go from right. 初めて小さくなる部分をつける。右から見ていき初めて小さくなる部分をつける。うん。What it does is the same as the before. Oh, there's a bunch of things. Pivot index. 比較の収支 Okay, this guy's also starting from the one before the end. While pivot index larger than -1 and nonce pivot index. Okay, so pivot index might like go past by the range of the array. So yeah, of course. Nonce pivot index plus 1. So index nonce 1. So this solution and this solution both are trying to get the position where the value gets smaller than before. So for example, we're starting from 2 and we move on we start from 3 and then we are going to look for the one next to it, and 3 compared to 2 is larger, so move on. 4 compared to 3, larger, move on. 1 compared to 4 is actually smaller, So you want to get this position, and this part is also doing the same here. Same, yes. And if after all you get -1, then you want to reverse everything. Are you sure? I'm not sure about that. Yeah, if it reaches to the end, that means, I mean, if it go past the end, it means everything is larger than the right part. So it is the, oh, I gotta call for my mom. So I have to get going. I'm going to be right back. Okay. Alright, I don't know. I don't remember what I have been. Oh. Alright, I'm back. Okay, more or less the same. So first, reverse, last, left is sorted until reverse, first, reverse, last, first, last. Pair of iterators defining the range of elements to permutate. Okay. All right. Hold on. And when I was looking at the other people's solution, they are looking for a position where it starts to get decreased. So let me enlighten myself. So in this case, okay, so in this case, You can't increment here. It's getting bigger, it's getting smaller. And here, it's gotten smaller. Here, this is getting bigger, it's gotten smaller. What I'm thinking right now is that how could I have realized that I only have to find a position where it starts to get decreased rather than finding a position where there's a larger element on the right part. Because the latter part that I came up with, it costs like more computational complexity than the other one. And when I'm looking at the code, okay, if not swap index. Well, num swap index, num's pivot index. Because if you do this, if you're ensuring the right hand is smaller than the other, if you keep moving on, you only have to compare the one next to it to see if there is any bigger value on the right hand. Yeah, that's clever. Okay, I can do that. So they say it's pivot index, so I can do it. Length nums -2 and while pivot index is is larger than -1, and nums pivot index nums pivot index -1. You want to exit the loop if pivot index becomes less than -1. Becomes less than -1, or nums pivot index -1. It should be larger non-pivot index -1. The one on the right hand is larger than that, so we want to stop that if that is the case. And what we want to do is the pivot index decrement after the loop if pivot index equals to -1. That means we want to return nums reverse reverse nums. And additionally, if it stops somewhere in the array, that means pivot index points at the place where nums pivot index and nums pivot -1, nums pivot -1 is larger than the other. So what we want to get is a swap index. Let's initialize that. But like okay. Swap index len nums -1 while pivot index swap index is larger than pivot index, and we want to get the minimum value. So nums no for I in range pivot index plus 1 nums I we want to get the minimum. We want to get the minimum. How do we get the minimum? Swap index, pivot index, swap index. Oh no, it's not -1, it's actually +1. I just typoed. And I didn't understand this part. Swap index, num swap index, nums pivot index. We want to keep decreasing swap index from the end, and you basically want to find when swap index becomes larger than a pivot index, but it has to be minimum larger, right? That's okay. Does that satisfy minimum larger element? Not particularly sure about that. Let me consider the example here. So you want to reorder this. You want to start from 7. It's getting bigger, it's getting bigger, it's getting smaller. This is getting bigger, this is getting bigger. 7. Yeah, cause yeah, cause as by the time you will reach to this process of the program, it is ensured that on the right part simply increases from the right to left, and if you have reached to the first that's larger than 6, that's a minimum larger. Okay, that makes sense. So let me do this one. Num swap index, nums swap index must be smaller than that. So swap index decrement, and once it goes to the position where swap index becomes larger than nums pivot index, right? Yeah, exactly. And then what you're gonna do is the nums swap index nums pivot index equals to nums pivot index nums swap index and nums pivot index plus 1 to the end should be sorted, right? So sort, I guess, and then return nums. Maybe that. Permutation. What? Returns none? No, no way. What do we have to return? We have to return array, right? Okay. So we don't have to return anything. Okay. Because we are doing it in place, so no wonder. And also reversed. Okay, so nums reverse. Okay. So let me see the result. Not the result, I mean the solution. Reversed. He's doing something else. Probably in this way it doesn't work, I guess. Oh, but it's doing reverse, not the sort. Not sure about that. Pivot index. Nums reversed. Okay, so it's already sorted. Yeah. If this is met, if, how do you say? Where is it? Okay, so if this condition is met, that means it's descendingly ordered. So yeah, you just have to reverse, not sort. Okay, I think that's it. I have to get going, so I'll be right back. Bye bye. All right, let's resume. It's been one night since I paused the recording, so as you can see, my clothes changed, and let me leave for a while to turn off the light. I mean, turn on the light. Okay, so let me make it bigger. Where have I been? Okay, so we actually, oh shit, I actually finished typing this, and I wasn't sure if this part would work. And let me check in Python documentation. Reverse. Array reverse. List reverse. V split. Okay, I'm not sure. ed run python. So let me just do the experiment. We have nums equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and then nums reverse. Of course, what it does is to reverse it, right? And then you do it twice, and then you have you have that you had at the first place, and let's say 3, and that will give you a slice from the index 3. And if you call reverse on this one, 1, 2, 3, 4, 5. Okay, so it doesn't change anything actually. So slice slice is just a copy, I guess. Array slice is a copy. In Python, when you slice a built-in list or tuple, a shallow copy of sliced portion is created. Okay. So if you want to do this, equals to not reversed nums 3, and then you get it. Yeah. Alright, so point proven. Going back. Oh, v-split view of step.1. Okay, and then if you want to get it reversed, we want to do reversed nums pivot index plus 1, actually a slice of it. Okay, I think this is it, and I don't need this one. And let me verify this solution. So let's say you have like this array, and you want to get this one as the next permutation. Pivot index initialized, so we have like 9 elements. It will point at the place where 8 exists. And pivot index minus 1, nums pivot index. Okay, so nums pivot index is 8 right now. And this is not minus 1, it is actually plus instead of minus 1. Right, so compare 8 with 9. 8 is obviously smaller than 9, so it doesn't go into this loop even. So pivot index is minus 2, and this one does not follow. Swap index goes to minus 9, goes to 9, and swap index 9 versus 8. 9 is bigger. So swap index is minus 1. And so 8 and 9 will be swapped. And nums pivot. Alright, then you want the right hand from pivot index to be as small as possible. And because we have flipped 8 and 9, um, what we want to do is to find like where value starts to get decreased, and you want to flip that value with another value that has minimum larger amount. So you want to sort. Reverse. Um, Let me think over. So it has been increasing, and we stop at a place where it starts to decrease, and we want to replace that number with the existential value. So far, that's the minimum larger amount of that, and we flip it over. We flipped it over. So that means this value is smaller than the other value on the right part. So it's still, when you look at the right part, it's still um, increasing consistently. Right, so you just have to reverse it. Okay, let me test with this example. Which example is best? I think this example. This is given, and we have pivot index, we have swap index, and let's say nums. And one. Pivot index is, so we have, how many values do I have? Okay, 9 values. That means we have length of 9 minus 2, 7. Alrighty, so okay, we can just say this is same, S as in same, and move on to the next iteration. Pivot index is bigger than -1. Yes, nums pivot index nums pivot index is 0, 1, 2, 3, 4, 5, 6 is 9. So nums 9. What? Hold on. Pivot index is not 7, right? Because we have 9 elements. 7. Okay. No, hold on. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so it's 8 versus 7. 8 versus 7. 8 is larger than the other. Yes, it is. So pivot index is decremented. Okay. And then 3. So we are going to this one. 9 versus 8. Yes, it's larger. So 5. Fourth iteration. We have 6. 6 versus 9. It's not compliant. So does not do anything. So 5. We save 5. And let me verify that. 0, 1, 2, 3, 4, 5. Yes, 5 is where 6 is. Yeah, so that is the pivot index. And then we are going to, okay, so we're not going to this part since pivot index is larger than since pivot index is not -1, does not do anything. Swap index will be initialized at the 4th iteration. So in the 4th iteration, we get 8 as swap index. And what we do, we can go to the 5th iteration, let's say that. And swap index versus pivot index. Alright, comparing where 6 is and comparing where swap index is. So swap index is at 7, and first appear bigger than that, bigger than where pivot index is, will be initialized as swap index. So okay, let me do that. Nums swap index, so 7 compared to 6 is larger than that, so swap index will be 8. Okay, because we are not doing anything here, let's stay on 5 iteration. So 5 index at 5 and index at 8 will be swapped, so that'll give at the 5th iteration, that'll give 6 will be 7, 7 will be 6. And as you can see, we are replacing with the value on the right hand, which consistently goes increasing, like consistently increasing as it goes to the left, and we're replacing it the exact value that is the um, that is like smallest larger value than the pivot than where pivot index is. So that means, hold on, I have some warning about battery running up. Anyways, so that means this, let me say, trait that the right hand keeps going up as it goes to the left is preserved. Yeah, it's preserved. So we can just, in order to make it smaller number, the smallest number, we can just reverse it. So that's why we are doing at the end this process. Okay, so what we're going to do at the sixth iteration is to reverse it. Let me make it easy for you, for myself actually, not for you guys. Okay. So pivot index is here, plus 1 here, from here to the end. Reverse it. So what it does, 9 becomes 6. 6 becomes 9. That is the answer. And that corresponds to what was given here. So this was given. This was the given value. 1, 2, 3, 4, 5, 6, 9, 8, 7. And that is what we want to get right below. 1, 2, 3, 4, 5, 7, 6, 8, 9. Okay, that's what we want to get. So apparently it works, and I just need to like submit to lead code. Okay, let me try sign up. Let me log in, and for the sake of security, I'm gonna pause for a bit. Okay. All right, there we go. So we have this code uploaded. I'm running the test to see if it passes the test case. Yes. So let me submit it. Yes, it passes. Okay, cool. So so far what we have done is to do the experiment, generalize something based on realization. We also took a look at some other sources, other approaches that other people called it. I mean, I took a lot of inspiration from those, and also I hit the code, run the code, it passes. So what I'm going to do next is a step 2, which step 2, so we're moving on to this step 2 in which I will be refactoring the code. Okay, so if when you see the code for improvement, the index is y. I for a second I thought returning nums reverse is a bit misleading. Nums reverse does not return anything, so it result like it ends up with returning none, but it looks like it's returning reverse array, which is not like common comprehension for Python programmers, but for those who came to Python world, maybe they're beginners, they're trying to figure out how Python works. It looks like it's returning a reverse version of the num array. So maybe I'm thinking about doing something like this. Reverse it and then return none, or return it, just return. So by writing this way, you know this method like this method affects nums, not like copying, like not like returning the copy of nums. So I think this is much better, I would say. So let me write it over. Reverse. I thought this part might be misleading for Python beginners, as it may introduce an idea that this is returning the reversed array. But this is not correct. This is not what it's doing. By separating this part, okay, let me write updated code. Nums reverse return. Oops. By separating this part, you can understand that reverse method destructively reverses the array nums. Okay, and then swap index. I don't think there's much to be done around here. Reversed, but I can write something regarding this one. Python some array, slice of something, index t, index head, reverse. I learned that this operation does not reverse the array. Let's say reverse the sliced array in place. Apparently, slicing creates a copy of the original array. And let me put the source. Slice. Shallow copies of dictionary can be made using an of list by assigning a slice of the entire list. Okay. Where is it? Where is it? Okay, there we go. Okay, there we go. Step 3. That's where we measure time to see how long to see how long do I take until I solve this problem. Okay. Now, oh, what I did, yeah, okay. I had to create another copy. Okay, let me say let me yank this. Hold on. Let me yank all of these and edit step 2. And in order to paste everything, I do this and then fuck. Hold on. Okay, there we go. Save it. And we can copy this first 2 lines of code. Edit step 3.py. Okay, and let's just start. So first I want to find pivot index, which is initialized as the index, the one before the end. Okay, and then while pivot index is larger than 1, and I have a message. Okay, and nums pivot index is larger than the one on the right. And if that is the case, decremented. Am I sure about that? Pivot index, when pivot index becomes -1, then you want to exit the loop. So yes, this part is correct. And if pivot index is where when pivot index is when its value starts to decrease compared to the one on the right, you want to go out of the loop. So invert that logic. Pivot index is large. Okay, yeah, that's correct. So now we have got the pivot. Like now we have identified pivot index. We have edge case to deal with it, because pivot index might be -1, meaning there's no next permutation. In that case, we want to nums reverse and then return it right there. Also, okay, so if that is not the case, that means we have next permutation originating from the nums array that's given as a parameter. So next we want to get a swap index, which is initialized a length of nums minus 1, which points at the end of the tail, which points at the end of the array. Okay, and now while nums pivot index and we want the least larger larger value than nums pivot index. So the first to encounter a large value, nums pivot index and nums swap index swap and if we go out of the loop, that means you have hit the first swap index whose value that points to it is actually larger than pivot index. And so no, it has to be this instead of the other. Yeah, exactly. So nums pivot index nums swap index equals to nums swap index nums pivot index. Got some message. Anyways, alright, so you swap it and you want the right part to be the smallest. So nums pivot, actually slice, you want to slice, equals to reversed version of nums pivot, just like that. Am I correct? No, slice. Just like that. Okay, so let me post it on LinkedIn. Not LinkedIn. What the fuck am I saying? On LeetCode. Yes, okay. I got it right. 6 minutes 18 seconds. Not pretty bad. Okay, so I solved the problem in 6 minutes and 18 seconds. All right. I realized something for the step 2. I can return nums when the size of it is 1 in order to make it faster. So let me put it. Return nums if length nums equals to 1. But it's not Ruby. If it's Ruby, I can do this, but it's Python, so I can do this. If blah 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 returns nums. Nope. Actually, return none. I mean, I don't like this either. Delete. Okay. And let me just in case put it on lead code to see if it runs as expected. I mean, it's just handling edge case where the length is 1, so it should, yeah, just like that, it works. Alright, so I think that's it. Whoop, memo no write last change, no write since light. Alright, we have everything here. Let me open up step 2, step 1, just in case, to check everything is saved. Yes. What about 2? Yes, we have everything. What about memo? I'm worried about that. Yes, we have everything. Alright, I'm going to ask Claude to translate everything in Japanese that's written in memo.md and put the translation at the top of a file. Translate memo.md in Japanese and put it at the top of the file. Alright, I'll see you in the next problem. Until then, have a great day. Bye bye. Ciao ciao.